Good morning and welcome to my YouTube channel, Pearson and Excel International Maths. And in this video, I want to introduce topic number 3 of Pure Mathematics 4. And we will be looking at coordinate geometry in Pure Mathematics 4. And under that topic, we shall be talking about a subtopic, which is parametric equations. And as it is written on page 17, we are looking at page 17. You can write the x and y coordinates of each point on a curve as functions of a third variable. And this variable is called a parameter and is often written in letter T, parameter T. A parameter in general language is something that is designed to explain something else in a hidden way. I want to explain the coordinates on the x-axis, but instead of giving it the name coordinates directly x, I am using t. T is in a different relation on, of course, with x, but it is x coordinates in a hidden way. And of course, a curve can be defined using parametric equation. For example, if you talk about x is equals to pt, a function of t, and y is equals to qt, each value of the parameter t defines a point on the curve with coordinates. Of course, if x is the function of t, pt, and y is pt, so the point, let's say point A, can have coordinates pt, qt, depending on what t is and how we are going to substitute the value of t, of course, to give x. For example, if you are told there is a curve like there's a curve like this here. There's a curve like that, and x is given by t squared plus 1 over t, and y is given by 2t. Of course, if you would want to tell the point, the coordinates of the point when t is equals to, let's say, 2, the coordinates of the point when t is equals to 2, then x becomes, this is of course 0, 1, 2, 3, 4, and all. That is y, and this is x. When x is equals to 2, then we talk about 2 squared plus 1 over 2, which is 4 plus 1, 5 over 2, which is 2.5. And that is x. For y, we have 2 times 2, which is 4. So we are talking about point A having coordinates 2.54. And that is just like what we need to understand generally, even before we get closer to the topic. And I want us to just know that for parametric equation, x is equals to pt and y is equals to qt, these equations, with Cartesian equation y is equals to fx, it is important to note that the domain of fx is the range of pt. The domain of fx is the range of pt. We are going to understand this further. And the range of fx is the range of qt. We will explain this further in examples. Of course, I want us to go directly to example 1. And we are told that a curve has parametric equations. X is equals to 2t, y is equals to t squared, and the range of t is between -3 and +3. And part A of the question, find a Cartesian equation for the curve. Find a Cartesian equation of the curve in the form y is equals to fx, yani in a general kind of form, the way we know curves or functions to be. And in an attempt to do this one, of course, we know that if x is equals to 2t, we need to make t the subject of the formula so that we can exactly see the relationship. So t is equals to x over 2. And y is equals to t squared. So therefore, if you want to make y the subject of the formula in this kind of format, because we are going to make y the subject of the formula, we must now substitute the value of t when we were dealing with x. So substituting t here, we're saying y is equals to x over 2 squared, which is which gives us y is equals to x squared over 4. And this is just a quadratic. This is a quadratic. You can see this is a quadratic equation. It is a quadratic equation, or it is a quadratic function. Part B talks of part B of the question talks of what? State the domain and the range of fx. State the domain. State the domain and range of fx. State the domain and the range of fx. And the moment we're talking about the domain, when x is equals to 2t and t itself is all the way from -3 to 3, substituting the least value here, x is going to be -6 on the lower side, and x is also going to be +6. So if you talk about -6, x is greater than -6 and less than +6. And to me, this is the domain. So the domain of f is the range of the parametric functions of x. So the range of x is equals to 2t over the domain over the domain, these boundaries, -3, 3 becomes -6 all the way to +6, because we have understood that the domain of fx is the range of the parametric equation. What do you mean by the range of parametric equation? So when we substitute in the function of x, then we get this upper and lower, the upper and the lower boundary. So I would wish to talk of the range. This is the domain. This is now the domain. What about the range? What about the range? The range is obviously the value of y. The range is obviously the value of y. And y is going to be, y will always be t squared. And t is -3 all the way to +3. And this gives us, when -3 is squared, gives us 9. When +3 is squared, gives us 9. Of course, when any number is squared, the least value it can assume is 0. When t is 0, squared is 0. So the range itself. So the range is all the way 0 to +9 because of this square. And any number is squared, then we cannot have negative numbers. And the third part of the question is sketch the curve within the given domain of t. sketch the curve within the given domain of t. Sketching the curve within the given domain of t. Of course, this is along x-axis. When x is -3, y is -6. When x is +3, no, not y, but x is +6. And when x is -3, y is 9. When t is 0, x is also 0, and y is 0. So when t is 3, x is 6, and of course, when t is 3, y is 9. So we are having this kind of range. And sure enough, because when we talk about y is equals to x squared over 4. So when x is 6, let's see this. When x is 6, so y is equals to 6 squared, which is 36, over 4, which is basically 9. That is exactly what we have had. Okay,